So here we have the 2015 AP Calculus free response question number 1. And the question is, the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 sine of t squared over 35 cubic feet per hour. T is measured in hours and t is less than 0 and greater than 8. I mean, t is greater than 0 and less than 8. I'll just go from here. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t, which is equal to negative 0.04 t squared plus 0.4 t squared. Okay, I'll just go from here. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t, which is equal to negative 0.04 t cubed plus 0.4 t squared plus 0.96 t cubic feet per hour, for which t is greater than 0 and less than 8. There are 30 cubic feet of water in the pipe at time t equals 0. So we know that water is flowing with the equation of r of t, and some of it is getting out by d of t. So A is how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. And so because we're figuring this out, we need to use the integral from 0 to 8, and since it's how much is flowing in, we're going to use the equation r of t dt. And once you plug that into the calculator, you get 76.570. That was A. B is asking, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. So here we have to figure out, our equation is going to be A of t, and we're going to have 30 because that's the initial amount that's already in there, plus the integral of 0 to t, and since it's how much is flowing in is r of t dt, minus the integral from 0 to t, and we also have to get how much is getting out, so it's d of t dt. And we're finding the derivative of this, which means that the integrals would cancel out and the 30 would also cancel out. So then you're left with A of t is equal to r of t dt minus d of t dt. And then we're figuring out for it at time equals 3. So you just plug in the 3. And then when you plug that into the calculator, it's less than 0. And since it's less than 0, we have to write that the amount of water is decreasing at time t equals 3, because the derivative of A of t is negative. And question C is asking, at what time t is this is the amount of water in the pipe at a minimum. Justify your answer. So what we're gonna do is that we're gonna write a chart to represent our values, and here we're just gonna call this W of t. So first we have to place our endpoints 0 and 8, and we know that 0 is 30 because that's the beginning position, but we need to find what 8 will be. So we start with our table, and we have to consider the two endpoints 0 and 8, and we already know that at time equals 0. Okay, so letter C is, at what time is t greater than 0 and less than 8 is the amount of water in the pipe at a minimum. Justify your answer. So what we have here is a table T to represent the values, and W of T to represent the value of this. So we already know that 0 is the beginning, so the value is 30. And then our second endpoint is 8. And to figure out the value of 8, we just plug it into the equation of 30 plus the integral from 0 to 8, r of t minus d of t dt. And when we plug that into the calculator, we get 48.54, which is how we got this. And then we need to find the local minima of this whole thing. So the local minima represents where the water flow changes from negative to positive. And then our second endpoint is 8. And to figure out the value of 8, we just plug it into the equation of 30 plus the integral from 0 to 8, r of t minus d of t dt. And when we plug that into the calculator, we get 48.54, which is how we got this. And then we need to find the local minima of this whole thing. So the local minima represents where the water flow changes from negative to positive. And what we do is that we need to graph it in the calculator and find the 0. And once we find the right and left bounds, what we get is 3.27. And to figure out its value, what we do is the same thing that we did with the 8, is that we just plug it into the equation, 30 plus the integral from 0 to 3.27, r of t minus d. D asks, the pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So we don't really have to do any math for this, but so it's saying that the whole thing has to equal 50, so we put 50. And we're just going to use the same equation that we've been using, except that it's just going to be for another value, which in this case is w. So 30 plus 0 of w, r of t dt minus the integral from 0 to w of d of t dt. And that's it. And that's all you need to write for that question. So that's it.